Imagine you're standing in the middle of the Yucatan Peninsula, right? And it's about 66 million years ago.
Just waiting for the end of the world.
Exactly.
Yeah.
You're looking up at the sky, and you're expecting to see this fiery, apocalyptic asteroid falling from deep space, like the ultimate cosmic bullet with Earth's name on it.
Because that's what we've all been taught, right?
Right. But what if you were looking the wrong way? What if the rock that killed the dinosaurs didn't come from the sky at all, but, actually exploded out from directly beneath your feet?
It completely inverts the most famous extinction story we have. I mean, we are all taught the textbook narrative, which is...
Giant space rock hits Earth, dinosaurs die, skies go dark, mammals take over.
Yeah, exactly. It's treated as an open and shut case, the ultimate settled science.
But today, we are taking that exact textbook narrative and just completely dismantling it. We're going to build something entirely different. So, welcome to today's deep dive.
It's going to be a wild one.
Oh, absolutely. Our mission today is to explore why, according to a fascinating alternative framework, the asteroid that killed the dinosaurs is, well, not what scientists believe it to have been.
Right. We're pulling from a pretty massive stack of source material today.
Yeah, it's all centered around Darrell Waters' Unified Theory of Geologic History, or UTGH for short.
And we have a lot to cover. We've got a highly technical white paper, a Sunday school study guide called Reading the Rocks, a young reader text titled Earth, 2 stories, and the core comprehensive book, which is called Earth, a biography of chaos.
And just to give you the proper historical context here, this entire framework actually builds upon the foundational hydroplate theory, which was originally developed by Dr. Walt Brown back in the 1980s.
Yes. And to set the stage properly for you, we really need to clearly establish the core premise of what we're talking about today.
Right, because we are going to examine 2 fundamentally different ways to read the exact same physical evidence.
Exactly. So the standard model of geology is known as uniformitarianism. That's the baseline assumption that Earth's surface features, the Grand Canyons, the massive rock layers, the vast fossil records, they were all formed slowly.
Like gradually, over millions and billions of years.
Right. Driven by the exact same geological processes we see operating today. So if a river carves a millimeter of rock a year, then a mile-deep canyon takes millions of years.
The present is the key to the past. That's the classic phrase.
It is, but the UTGH framework proposes something radically different. Now, it does agree with standard astrophysics that the universe and the Earth's foundational rocks are ancient.
Like 4.5 billion years old.
Yeah, it doesn't dispute that. However, it argues that the surface of the Earth, all those sedimentary layers, and the fossil record trapped within them, was not formed slowly at all.
This is where it gets crazy.
It really does. It argues the surface was violently, catastrophically reshaped by a single planetary scale event called the rupture event, approximately 5,300 years ago.
Which is just a massive paradigm shift. And it is crucial to state right up front for you listening, we aren't here to take sides.
No, not at all.
We aren't here to endorse a specific viewpoint or, tell you what to believe about the history of the world. We are just here to impartially report on the content provided in these sources.
Because the way this framework attempts to solve long-standing scientific anomalies is undeniably fascinating, regardless of where you stand.
Totally. We're looking at a framework that claims the Chixulub asteroid wasn't a visitor from outer space, but actually a piece of Earth's own deep crust coming home. So, okay, let's unpack this.
Right. To understand the UTGH alternative, we first have to thoroughly understand the mainstream consensus. What exactly is the standard model smoking gun for this asteroid?
It all comes down to a very specific boundary, doesn't it?
Yes, a globally distributed boundary layer in the geological record called the Cretaceous-Paleogene, or KPG boundary.
And this is the layer that basically marks the end of the dinosaur era all over the world.
Exactly. And right at that boundary, there is a very thin layer enriched with a rare element called iridium.
And iridium isn't something you just find while digging in your garden.
No, it really isn't. Iridium is what geochemists classify as a cytophile.
Which means iron-loving, right?
Literally, yes. Iron-loving. And why does that matter? Well, during the early molten formation of the Earth, planetary differentiation occurred. Some call it the iron catastrophe.
That sounds intense. What is the iron catastrophe?
It just means that the vast majority of the planet's heavy iron sank all the way down to form the Earth's core. And because iridium chemically loves to bond with iron, it rode that iron all the way down.
So it all sank.
Right. Consequently, iridium is incredibly rare in the Earth's surface crust today. However, it is quite common in certain types of meteorites.
Specifically chondrites, if I remember the text right.
Yes, chondrites. They're essentially undifferentiated space rubble that never underwent that sinking process. They still have all their original iridium mixed in.
So, I mean, the logic of the standard model makes total sense here. If you find a global spike of iridium sitting right on top of the last dinosaur fossils,
And you know iridium doesn't naturally exist in high concentrations on the surface?
yeah, then you conclude it had to come from space. Ergo, a giant asteroid hit the Earth. Case closed.
It is a highly elegant deduction, it really is. But what's fascinating here is how the UTGH framework looks at that exact same iridium layer and reaches a completely inverted conclusion.
Just based on the mechanics of the Earth itself, this is where the story completely flips.
Right. The framework asks, what if that rock wasn't from space?
UTGH argues that the Chixulub impactor, the giant object that carved out that 93-mile-wide crater in the Yucatan, was actually a fragment of Earth's own mantle-enriched deep crust.
Yes. The theory proposes that during this catastrophic rupture event, a massive chunk of deep Earth rock was launched into a ballistic orbit,
Just shot straight up into space.
traveled up into space, and then simply returned to strike the Earth weeks later as the planet rotated beneath it.
It changes the entire geometry of the extinction event. It really makes me think of, like, a strange crime scene.
Oh, how so?
Well, imagine a detective finds a very rare, high-caliber bullet embedded in the ceiling of a living room. The immediate logical assumption is, a sniper must have shot this from a mile away through a window.
Sure, that makes sense.
But then the detective looks closer at the floorboards and notices they are splintered upward, pointing toward the ceiling. The bullet didn't come from a sniper outside. A specialized high-pressure weapon exploded down the basement and shot the bullet straight through the floor.
I see. It's the exact same evidence. The bullet is real, the hole is real, but the trajectory is entirely reversed.
Exactly. But, I mean, in the realm of physical science, an analogy isn't enough. You need testable, falsifiable predictions.
You do. And this raises an important question for you listening. How do you chemically prove if that iridium came from a space rock, or if it came from the Earth's own deep mantle?
Right, because both places have iridium.
Exactly. The UTGH framework highlights that there is a decisive geochemical measurement that can settle this. It's not just about the presence of iridium, it's about isotope ratios.
The chemical fingerprints of the elements. Let's break down what an isotope actually is for a second, just so we're all on the same page.
Of course. An isotope is simply a variation of a chemical element that has the same number of protons, but a different number of neutrons.
So it's like a slightly heavier or lighter version of the same element.
Exactly. Some isotopes are stable, but others are radiogenic. That means they are the product of radioactive decay over billions of years.
And the sources point to a very specific set of elements for this.
Yes. We are looking specifically at the osmium, iridium, and ruthenium isotope ratios at the KPG boundary. And the UTGH framework points directly to the ratio of osmium-187 to osmium-188.
Okay, so why do those two specific isotopes matter so much in this debate?
Because osmium-187 is radiogenic. It is slowly produced by the decay of another element, rhenium-187, over vast stretches of time.
Okay, I follow.
Now, deep inside the Earth's mantle, the specific chemical environment has allowed a very particular ratio of these osmium isotopes to develop. Meteorites out in space have a totally different evolutionary history, so they have a different ratio.
Ah, so they literally have different serial numbers, essentially.
That's a good way to put it. If the standard model is correct and an asteroid hit the Earth, the isotopic signature in that KPG boundary layer should perfectly match chondritic or meteoritic material.
And what is that number? The text gives a very specific measurement.
It does. That specific ratio in space rocks is approximately 0.1262.
Okay, 0.1262.
Right.
That's the space rock number.
Yes. But if UTGH is correct, and the material was actually launched from the deep, highly pressurized zones of Earth's own crust and upper mantle, where, remember, iridium and osmium do exist in higher concentrations, the ratio will be distinctively terrestrial.
Yeah, and the Earth rock number is different.
Very different. The Earth's upper mantle signature is between 0.1070 and 0.1250.
So the math is literally sitting right there waiting for us. The space rock number is 0.1262, and the Earth rock number maxes out at 0.1250.
Right. We are talking about a microscopic numerical difference, but it is the literal difference between an alien asteroid from deep space and our own planet exploding from within.
which is wild. So why haven't scientists just run the test to see which number it is? It seems so obvious.
And that is perhaps the most revealing observation in these texts regarding the sociology of science. According to the UTGH authors, this is a profound blind spot in the scientific community.
A blind spot. How do you just miss that?
Well, these incredibly precise isotopic tests haven't been widely or definitively run to differentiate these specific origin points at the boundary. Why? Because the asteroid hypothesis was already universally accepted as fact before the technology to do this precise isotope testing was even widely available.
Oh, wow. It's the classic paradigm problem.
Precisely. The philosopher of science Thomas Kuhn wrote extensively about this. Once a scientific paradigm becomes dominant, the very questions scientists ask change.
They stop asking if it happened and start asking how it happened.
Exactly. They start asking questions about how the asteroid impacted or what the specific environmental effects were, or where the dust settled. They completely stop asking whether it was an asteroid in the first place.
Right. The alternative question that it came from below simply wasn't formulated by the mainstream.
So the specific test to prove it wasn't funded or prioritized.
It's like looking for your lost car keys in the kitchen just because the overhead light is better there, even though you might have dropped them in the dark hallway.
That's a great analogy.
If everyone in the house agrees the keys are definitely in the kitchen, nobody ever brings a flashlight to check the hall.
But I mean, I have to say, this leads us to the most obvious, glaring question of this whole deep dive.
Which is, if that Chixulub rock was actually a piece of Earth's crust falling back down, what on Earth literally could generate enough force to shoot a rock the size of a modern city completely into outer space?
Right, and if we connect this to the bigger picture of the framework, we arrive at the absolute central engine of the entire UTGH model, the rupture event.
Let's get into this, because the physics described in these sources are just staggering.
They really are.
According to UTGH, the pre-flood Earth was structurally, physically different than the planet we inhabit today.
Fundamentally different. About 60 miles, or 96.6 kilometers, below the surface, there was a massive, global, interconnected reservoir of water.
But the text is clear that it wasn't just a subterranean lake, or like a dark, peaceful underground river.
Far from it. At a depth of nearly 100 kilometers, the physical conditions are extreme to the point of being alien to us. The framework calculates that this subcrustal ocean was trapped under more than 40,000 atmospheres of pressure.
40,000 from the weight of the crust above it.
Yes, from the sheer weight of the granite crust pressing down. Furthermore, the temperatures down there exceeded 2,500 degrees Fahrenheit, or about 1,370 degrees Celsius.
So just unimaginably hot and squeezed.
Exactly. And under those incredibly specific conditions of high heat and crushing pressure, water enters a state of matter called supercritical.
Supercritical fluid. This isn't just hot water.
Right. It behaves as neither a true liquid nor a true gas. It completely loses its surface tension. It becomes an incredibly dense, highly energized fluid solvent.
The book says it can dissolve minerals, right?
Yes. Supercritical water can dissolve minerals, like quartz, as easily as warm water dissolves sugar. It was essentially a planetary scale pressure cooker, highly volatile, and wound as tight as physically possible.
But a pressure cooker needs a trigger to finally blow, a structural failure. So what actually sparked it? The text points up into the sky for the answer.
It does. It points to the moon, specifically to a mechanism called tidal flexing.
Okay, let's break that down, because this is a crucial mechanism to grasp.
We are all familiar with the moon's gravity pulling on our oceans to create the daily tides, right?
Sure, high tide, low tide.
But the moon's gravity also exerts a pull on the solid crust of the Earth itself. The UTGH framework proposes that the pre-flood moon actually orbited closer to the Earth.
So the gravitational pull would be much stronger.
Yes. And for centuries, this stronger gravitational pull caused the Earth's solid crust to flex infinitesimally.
Just microscopic bending day in and day out as the Earth rotated.
Exactly. In engineering, this is known as material fatigue.
It's exactly like taking a metal paperclip and bending it back and forth in your hands. If you do it once, nothing happens.
Right. It holds its shape.
But if you do it 100 times, the metal fatigues, it literally heats up in your fingers, and eventually it just snaps.
And when this planetary paperclip finally snapped, it didn't happen slowly over millennia. The granite crust fractured.
And according to the mathematical models in the text, this crash propagated around the entire globe at what physicists call Rayleigh wave speed. Wait, Rayleigh wave speed? What does that actually mean in miles per hour? Are we talking about the speed of sound?
Faster, Rayleigh waves are a type of acoustic surface wave that travel through solid matter. In granite crust, a Rayleigh wave travels at roughly 3 kilometers per second.
Whoa.
That's nearly 6,700 miles per hour. At that velocity, a fracture could encircle the entire planet in a matter of hours.
The crust literally unzipped itself.
It did. And when that seal broke, all that 2,500-degree, 40,000 atmosphere supercritical water finally found an exit.
The decompression must have been insane.
It was violently catastrophic. The supercritical water exploded upward through the fractured crust at hypersonic speeds. The energy release calculated by the framework is almost difficult to comprehend.
Hit me with the number.
It's approximately 9.84 times 10 to the 25th power joules of energy.
Okay, I have to stop right there and push back a little.
Right.
Because 10 to the 25th power is just an abstract math equation to most of us.
Fair enough.
But more importantly, if an explosion of that magnitude goes off from beneath the crust, wouldn't the sheer thermal radiation literally melt the surface of the planet to glass? How does anything, let alone a wooden tree or a delicate dinosaur bone, survive to become a fossil in that kind of thermal environment?
That is a highly perceptive objection, and it's one the framework explicitly addresses through thermodynamics.
Okay, let's hear it.
The energy released was indeed equivalent to roughly 246 Chixulub asteroid impacts going off simultaneously.
246 asteroids. That is terrifying.
However, the energy didn't primarily manifest as conductive heat burning the surface. It manifested kinetically and through something called the latent heat of vaporization.
Meaning the energy went into movement, not just baking the ground.
Exactly. The vast majority of that energy was consumed by the physical work of lifting and accelerating an estimated 10 to the 22nd power kilograms of mass.
That's water, steam, pulverized rock, organic material.
All of it, lifted completely out of Earth's gravity well. Furthermore, when highly pressurized supercritical water flashes into steam, it undergoes an endothermic expansion.
Endothermic, meaning it absorbs heat.
Yes, it actually absorbs heat from its surroundings to change states so rapidly. So while the event was incredibly violent and destructive, the water itself acted as a massive thermal buffer.
Wow. So it prevented the crust from melting into a sphere of magma.
Exactly. The physics actually protect the rock.
That is fascinating. So this hypersonic blast launches all this mass into outer space. The framework argues that this ejected mass didn't just disappear, right?
No, it became the comets, the asteroids, and the dispersed minerals that we now see scattered across the solar system.
So the material that achieved escape velocity became cosmic debris. And the material that didn't achieve escape velocity, like our Chixulub impactor,
Fell back to Earth.
Okay, so we have a global crack in the Earth, shooting a 246 asteroid-level blast of boiling supercritical water and rock into space, tearing the continents apart and drowning the planet in a global flood.
It's a rough day for the planet.
To say the least. You would think that is what killed the giant dinosaurs, the sheer trauma of it all. But UTGH says something completely counterintuitive here.
It does. It says the flood and the returning debris falling from the sky were devastating, yes, but they weren't the primary reason the giant dinosaurs went extinct.
Which blew my mind. The real killer was something completely invisible. It was a permanent change to the laws of biology in the atmosphere.
This is where the framework takes a brilliant step out of pure geology and dives deeply into biomechanics.
Right, let's talk about the giants. Because to understand this, we have to look at the biomechanical paradox of the standard model.
The sauropods, like Brachiosaurus or Argentinosaurus, which weighed upwards of 100 tons.
Or the giant pterosaurs, like Quetzalcoatlus.
Yeah.
That was the flying reptile that stood as tall as a modern giraffe. The UTGH text makes a really bold claim here. It says that under today's gravity and today's atmospheric pressure, these animals are biomechanically nearly impossible.
And mainstream paleontology actually acknowledges these incredible engineering challenges. Let's deeply break down the math of a long neck, just as an example.
Okay, the Brachiosaurus.
To pump blood vertically up a 20-foot neck to reach the brain of a Brachiosaurus, the animal has to fight the immense pull of gravity. The heart must generate massive pressure just to maintain a column of fluid that high.
because gravity wants to pull all that blood back down to the feet.
Exactly. The UTGH calculations using standard hemodynamics show that a brachiosaurus would require roughly 440 millimeters of mercury of extra blood pressure just to overcome the vertical lift.
To put that in perspective for you listening, a modern giraffe, which is the tallest animal we have today,
Yeah.
needs about 132 millimeters of extra pressure for its neck.
Right.
So a brachiosaurus needs more than 3 times the blood pressure of a giraffe just to not pass out.
Exactly. And under today's physical laws, generating that much systolic pressure runs into a biological wall called Laplace's law.
Laplace's law, what does that dictate?
Essentially, to generate that much pressure, the muscular walls of the heart have to be incredibly thick and strong, but there is a biological limit to how thick a heart can be.
Oh, because it still needs room inside for the blood.
Precisely. If the walls of the heart get too thick, the internal chamber, the lumen, shrinks. Eventually, the heart becomes so thick and muscular that it wouldn't have enough room inside the chambers to actually hold the volume of blood it's supposed to pump.
It just becomes a solid block of muscle that can't function.
Yes. So under modern conditions, a brachiosaurus heart is a physiological paradox.
And it's not just the dinosaurs walking on the ground. You also have the flight paradox with Quetzalcoatlus. This creature weighed an estimated 250 kilograms.
Which is huge for a flying animal. The physics of flight relies strictly on the lift equation. And this equation is driven by several variables, most notably velocity and air density.
Air density, or rho, in the equation.
Yes. When you run the numbers for a 250-kilogram animal with the wingspan of a small airplane in today's air density, the minimum flight speed, the stall speed it must reach just to stay in the air, is roughly 62 kilometers per hour.
Which is physically impossible for an animal to achieve on the ground just by running or jumping to take off.
Right. It can't get to 62 kilometers an hour on leg power alone.
It's essentially an airplane without an engine. It would just sit there on the runway, flapping uselessly. Here's where it gets really interesting, though.
The framework solution.
Yes. The UTGH framework doesn't say evolution magically solved this with invisible, undocumented organs. It says the animals were perfectly normal. It was the world that was different.
The UTGH solution is the denser sky.
The denser sky. I love that phrase.
The framework proposes that the pre-flood Earth had a vastly different atmospheric composition. It proposes an atmospheric pressure of 1.5 to 2.0 atmospheres, with a central estimate of 1.8 atmospheres.
Almost twice what we have today.
Yes, and an oxygen content of 30 to 35% compared to our 21% today.
So it was a dense, highly oxygenated fluid environment.
And when you plug 1.8 atmospheres of density into the lift equation, the flight paradoxes disappear completely.
Because the air is thicker.
Right. The air is so thick that the giant pterosaur can generate sufficient lift at much lower biologically achievable speeds.
It's the difference between trying to swim in a pool of water versus trying to swim in a pool of honey, right? The resistance provides the lift.
Exactly. And for the Brachiosaurus, breathing dense, highly oxygenated air provides a massive cardiovascular assist.
How does thicker air help the heart, though?
Well, the higher ambient atmospheric pressure actually helps compress the vascular system, pushing the blood upward. And the high oxygen means the heart doesn't have to pump as large a volume of blood per minute to get the same amount of oxygen to the brain.
Ah, yeah.
The physiological load on the sauropod heart drops straight down into normal, viable biological ranges.
It's like taking a deep-sea submarine that would crush on the surface and putting it back at the bottom of the ocean. Suddenly, the engineering makes total sense because it's in the environment it was built for.
That's a perfect analogy.
I mean, if you took a brachiosaurus and dropped it in today's world, it would feel like standing up way too fast, constantly, until its heart gave out.
Yes, it would be suffocating and fainting simultaneously.
But the atmosphere is only half of the pre-flood equation. There's also the gravity calendar connection, and this is where we really need to slow down because this is where my mind was completely blown by these sources.
It is a profound part of the theory.
UTGH proposes that the surface gravity of the pre-flood Earth was 9.68 meters per second squared.
Which is about 1% lower than our gravity today.
Right. And a 1% reduction in gravity provides exactly the remaining physiological margin needed to make those giant dinosaur cardiovascular systems function perfectly.
But the truly fascinating part is how the framework derives that 1% figure. It doesn't just invent a convenient number to make the biology work.
No, it derives it entirely independently,
Yeah.
using ancient history, from calendars of all things.
It's remarkable. The text points out an incredible historical anomaly. Ancient civilizations all over the world, cultures that had absolutely zero contact with each other, used a 360-day calendar.
Not 365 and a quarter like we do today.
Yeah.
Exactly 360.
Yes. We see this in the ancient Mayan calendars, the early Egyptian calendars, the ancient Chinese, the Sumerians.
They all started with the same number.
They all initially calculated a year as 360 days, and many of them later had to add awkward 5-day intercalary periods to fix their calendars when they realized the solar year didn't match anymore.
Right. The Egyptians called them the demon days because they were so unlucky and out of place. But why would all these separate cultures independently choose 360?
If we connect this to the bigger picture, the math is incredibly elegant. The framework posits they use 360 days because, before the rupture event, the year actually was 360 days.
Meaning the Earth was spinning slightly slower on its axis.
Yes. And why was it spinning slower? Because it was physically larger. UTGH calculates that before the subcrustal water escaped, the Earth's radius was exactly 46 kilometers larger than it is today.
And we know this because of the law of conservation of angular momentum.
Precisely.
It's the classic ice skater analogy in physics. When an ice skater is spinning on the ice with her arms stretched out, she spins at a certain speed. But when she pulls her arms in tightly to her body, her mass is closer to the center of rotation. So what happens? She spins faster.
Exactly. When the subcrustal water evacuated during the rupture event, a massive void was left beneath the crust. Gravity took over, and the granite crust collapsed inward to fill that void.
So the whole planet shrank.
The Earth's overall radius shrank by 46 kilometers. Just like the ice skater pulling her arms in, the Earth conserved its angular momentum, meaning its rotational speed had to increase.
Wow.
The length of a single day shortened slightly, meaning it now takes 365.25 of these shorter days to complete a single trip around the sun, rather than 360 of the old, longer days.
I just want you listening to appreciate the weight of this mathematical convergence because it is stunning. The historical record of the 360-day calendar gives you the radius change of the Earth.
Right.
The radius change of 46 kilometers tells you exactly how much geometric volume of water was lost from the subcrustal ocean. That larger pre-flood radius also gives you the exact calculation for a 1% reduction in surface gravity.
Yep.
And that 1% reduction in gravity perfectly aligns with the exact cardiovascular requirements to keep a brachiosaurus alive. As the text says, they all independently converge on the exact same math.
It is a hallmark of a robust theoretical framework when multiple, completely independent lines of inquiry, in this case, human archaeology, planetary geometry, and vertebrate biomechanics, all arrive at the identical numerical solution without being mathematically forced.
It really paints a picture of a radically different world. A denser sky, lower gravity, giant creatures operating comfortably within their physical limits.
A world that is now gone.
Right, because that world was violently buried in a matter of days. Which brings us to a massive question.
Let's hear it.
If this pre-flood world was so perfectly engineered for these giants, where is the physical proof of its destruction? Because modern geologists look at the Grand Canyon and see millions of years of peaceful, gradual layering. How can a single catastrophic event involving boiling water create miles of stacked rock?
To answer that, the UTGH framework reinterprets the entire sedimentary record through the lens of fluid dynamics, specifically a process called hydraulic sorting.
Hydraulic sorting, so
Right.
sorting by water.
Exactly. When you have a catastrophic global flood event, you have massive continent-spanning bodies of moving water, and they are laden with unfathomable amounts of sediment, pulverized rock, and organic material.
Just a massive, muddy slurry.
Yes. As that water moves, it undergoes a process known as liquefaction. The water automatically sorts materials by density, size, and aerodynamic or hydrodynamic shape.
So it's not a historical timeline of millions of years. It's a massive physical filtration system.
Exactly. Heavy, dense objects like mineralized shells, solid clam beds, or compact vertebrate bodies, they sink first and fastest. Lighter, more buoyant, or more mobile creatures are carried further in the currents and sink later.
So the layers are laid down simultaneously, or at least continuously, just sorted by weight.
The framework argues that the entire fossil record is essentially a planetary-scale turbidite sequence.
What is a turbidite sequence?
It's a geological term for a rapid underwater avalanche deposit. The sharply defined sedimentary layers aren't pages of deep time recording millions of years of gradual accumulation. They are a hydraulic snapshot of a single catastrophe, sorted by the strict physics of water in a matter of weeks and months.
And this brings us to what the text calls the most uncomfortable exhibit in modern geology.
Ah, polystrate fossils.
Yes, poly meaning many, strat meaning strata or layers. These are fossils, most commonly massive vertical tree trunks, but occasionally large dinosaur bones, that are found standing straight up, penetrating vertically through multiple distinct layers of sedimentary rock.
Right. And under the standard model, those different rock layers are supposedly separated by tens of thousands or even millions of years of time.
But think about the basic logic of that. Imagine leaving a wooden fence post standing in your backyard. If you leave it there for 1,000,000 years, it doesn't just wait around patiently for the dirt to slowly build up and bury it inch by inch over millennia.
No, it would rot.
Exactly. It rots. The rain destroys it. Fungi eat it. It decays. For a tree to be fossilized standing straight up through multiple layers, those layers had to encase it fast all at once before it could rot.
Uniformitarian geologists are fully aware of polystrate fossils, of course. Their explanation relies on local, rapid, special cases to explain them away.
Right. They don't ignore them.
No. They frequently point to events like the 1980 eruption of Mount St. Helens. When that volcano erupted, it blasted a massive forest into nearby Spirit Lake. Over time, the waterlogged trees eventually sank vertically, root end down, into the rapidly accumulating sediment at the bottom of the lake, creating proto-polystrate logs.
So UTGH actually agrees with the standard geologists on the Mount St. Helens mechanism, the water logging, the vertical sinking, the rapid burial.
Yes, the physical mechanism is agreed upon, but there's a massive catch.
The catch is scale, isn't it?
It is entirely about scale. UTGH argues that Mount St. Helens is a perfect local demonstration of the exact rapid mechanism needed. But we don't just find polystrate fossils in one lake in Washington state.
We find them everywhere.
We find them globally across every continent, spanning geological sequences that the standard model insists represent millions of years of slow accumulation.
So to explain that under the standard model, you have to invoke thousands of disconnected, highly coincidental local flash floods or volcanic landslides happening perfectly over and over for millions of years.
Whereas UTGH argues that a global distribution of this forensic signature requires a global mechanism. The global floodwaters provided that exact Mount St. Helens mechanism, but on a planetary scale.
The text also brings up the Paluxy River tracks in Glen Rose, Texas. This is a highly debated, very controversial site where you have dinosaur footprints and what appear to be human-like footprints existing in the exact same mudflat.
Yes, that site has caused endless debate.
Because the standard model says that rock layer is 113 million years old.
Mm-hmm.
So human tracks are a literal impossibility, a complete category error. They have to be eroded dinosaur tracks or outright fakes.
But UTGH says, wait, if you remove the assumption of deep time, the paradox disappears. The tracks aren't 113 million years old. The mud was laid down contemporaneously during the rupture event's tidal fluctuations.
Meaning both sets of tracks were made by creatures fleeing the exact same catastrophe at the exact same time.
And this directly challenges another foundational assumption: how long rock actually takes to form. We are culturally conditioned to think lithification, the process of loose sediment turning into solid rock, requires deep time and immense pressure.
Millions of years of crushing weight.
Right. But the framework points to the London hammer as a proof of chemical principle.
Oh, this is a great example. It's a 19th century miner's hammer that was found completely encased in a nodule of solid rock in Texas.
When it was discovered, it caused quite a stir. Some claimed it proved the rock was recent, while fringe theorists claimed it proved ancient aliens left a hammer millions of years ago.
And mainstream science correctly debunked the alien theory, proving the hammer was of recent human manufacture.
But in doing so, they demonstrated exactly what UTGH requires. Lithification isn't about time. It's about mineral supersaturation in water, precipitating out as a cement-like calcium carbonate or silica between sediment grains.
So if the chemistry is right, it happens fast.
If the geochemical conditions are right, sediment can harden into solid rock around an object in mere decades.
Deep time isn't needed for rock to form. You just need the right chemistry. And the global flood, full of dissolved minerals and pulverized crust from the subcrustal ocean, provided the ultimate chemical bath.
Exactly. The floodwaters eventually receded, the subcrustal chambers completely collapsed, the newly formed ocean basins deepened, and the water drained off the continents.
But the Earth that emerged was fundamentally broken.
Yes. The thermodynamic aftermath of the rupture event created a world we would barely recognize today and initiated a cascade of environmental changes that would reshape the biology of the planet.
Let's look closely at that thermodynamic aftermath because it provides the mechanism to answer one of the wildest mysteries out there.
The mammoths.
Yes. How do you explain perfectly preserved woolly mammoths, buried in the Siberian permafrost, with undigested, fresh vegetation like delicate buttercups still in their stomachs?
It's a profound puzzle for standard climatology.
Right, because they didn't just freeze to death in a normal winter storm.
Yeah.
If they had, their stomach acids would have broken down the food while they were slowly dying or after they died. They were snap frozen so fast, the food in their mouths didn't even degrade.
The UTGH framework introduces a concept called adiabatic atmospheric collapse to explain this.
Okay, what is adiabatic collapse?
Remember the hypersonic mass expulsion during the initial rupture event? All that supercritical water vapor was launched high into the upper atmosphere and beyond into space.
Right.
When a highly pressurized gas expands incredibly rapidly into a lower pressure environment, its temperature drops precipitously. This is the adiabatic cooling effect.
Oh, it's the exact same physics as a can of compressed air for cleaning your keyboard.
Yes, exactly.
When you spray it, the can gets freezing cold in your hand because the gas inside is expanding.
Precisely. But this was that same principle applied on a planetary scale. When the supercritical water vapor expanded into the thin upper atmosphere, it caused a rapid, localized temperature crash.
So the sky itself just froze.
In the expansion zones, primarily over the northern latitudes, the atmospheric temperature plummeted to below minus 100 degrees Celsius in a matter of minutes.
Minus 100 degrees.
In minutes.
Any large animals like mammoths caught in those specific geographic zones were flash frozen instantly, preserving them in place with the vegetation still in their digestive tracts.
That perfectly answers the mammoth mystery. But what about the broader climate? The Standard Model teaches that the Earth has gone through dozens of slow ice ages over millions of years, driven by subtle orbital wobbles called Milankovitch cycles.
UTGH throws that out completely. It says there was only one ice age, and it happened immediately after the flood.
And it provides a brilliant thermodynamic engine to explain it. It does. You have to understand the paradox of an ice age. You can't just cool the Earth down to get an ice age. If you just make the Earth cold, you get frozen desert like Mars.
Right, because cold air holds less moisture.
Exactly. To get an ice age, you need massive amounts of precipitation, which actually requires massive amounts of heat.
Heat causes an ice age. That sounds completely backward.
It does, but think about the immediate post-flood world. You have oceans that are incredibly warm, heated by the immense friction of moving continents, and the 9.8, 4 times 10 to the 25th joules of geothermal heat injected by the escaping supercritical water.
Okay, so the oceans are basically high baths.
Yes. Warm water drives massive, sustained evaporation.
So the atmosphere is completely saturated with moisture. It's like a global sauna.
But at the same time, the rupture event injected massive amounts of volcanic aerosols, dust, and particulate matter high into the upper atmosphere.
Ash blocking the sun.
Yes. This created a global veil that blocked incoming solar radiation, particularly shading the continental interiors at higher latitudes.
So you have this massive thermodynamic paradox. The oceans are piping hot and evaporating, but the landmass is freezing cold and dark.
That combination, warm oceans pumping immense moisture into the air and cold continents causing that moisture to rapidly condense and fall, is the exact thermodynamic recipe for massive, continuous, relentless snowfall.
Snow that falls and never melts in the summer.
Right, because the summers are suppressed by the atmospheric aerosols.
Right.
This single massive mechanism built the polar ice sheets incredibly rapidly, in a matter of centuries, not millennia.
So what does this all mean for the animals living through this? Because the Ice Age wasn't just a frozen wasteland everywhere, was it?
No, it created a very specific temporary ecosystem called the steppe window.
The steppe window.
This warm ocean moisture regime fed a highly productive, high biomass steppe environment across vast areas of the northern hemisphere. It was cold, yes, but it was incredibly lush with deep vegetation.
This is the habitat of the woolly mammoth, the woolly rhino, the giant ground sloths, the megafauna.
Exactly. It was a temporary paradise for these massive herbivores.
But then they all died. And the standard textbook answer for why the mammoths died is the overkill hypothesis.
The idea that human hunting wiped them out.
Right. That early human hunters spread across the globe and basically spear hunted millions of massive animals to extinction. But UTGH says that's not the primary story. The mammoths didn't die because of human spears. They died because the steppe window slammed shut.
This is a beautiful piece of ecological synthesis in the text. Think about that thermodynamic engine we just discussed. It's driven entirely by the residual heat of the post-flood oceans.
Right, the hot oceans acting as the battery.
But oceans eventually cooled down. Over centuries, as the oceans lost their heat to the atmosphere and reached a new, modern equilibrium, the massive evaporation slowed down.
The battery ran out.
The rainfall patterns changed drastically. The lush, highly productive steppe biome simply dried up and collapsed.
Habitat disappeared beneath their feet.
Exactly. In biology, organism survival is fundamentally habitat survival. When the mammoth steppe collapsed into the modern, barren tundra and pine boreal forests we see today, the mammoths lost their massive caloric food supply. They starved.
So humans maybe hunted a few stragglers, but it was the climate crash that killed them.
Human hunting may have put pressure on the very last stressed, isolated populations, but the primary killer was the thermodynamic collapse of their ecosystem.
And what's wild is that the text applies this exact same logic to the ocean, specifically to the giant shark, the megalodon.
Yes, the megalodon is basically the marine mirror of the mammoth.
The warm post-flood ocean supported a massive biomass of prey, huge populations of whales and large marine mammals. But as the ocean cooled, that prey biomass collapsed.
And a predator the size of a megalodon requires massive caloric intake just to survive. It couldn't just downsize its appetite. When its food supply crashed, it crashed.
And this framework powerfully explained the geographic asymmetry of the megafauna extinction.
It really does. Why did the mammoths and ground sloths in North America and Eurasia go extinct, but the massive rhinos, hippos, and elephants in Africa survived?
Right. If human hunting is the sole answer, it makes absolutely no sense. Humans coexisted with African megafauna far longer than they did in the Americas.
It's all about the habitat. The African savanna is an equatorial ecosystem. Its productivity is driven by the consistent solar budget at the equator, not by the temporary warm ocean evaporation engine that built the northern steppe.
So they were safe from the ocean cooling.
When the oceans cooled and the northern steppe died, the African savanna persisted. The African megafauna survived because their habitat survived. They were never dependent on the temporary steppe window.
The elegance of that explanation is incredible. Everything connects. The heat of the flood drives the evaporation builds the ice age builds the steppe feeds the mammoths.
And then the ocean cools, the steppe dies, the mammoths die. It's a single logical chain of cascading consequences.
Which brings us back to the overarching philosophy of science that this entire deep dive has been exploring today. We have looked at two profoundly different frameworks: uniformitarianism and UTGH.
And as we've said, both are looking at the exact same data, the same rocks, the same fossils, the same genetics, the same craters.
But they are applying entirely different baseline assumptions. One assumes deep time, slow processes, and extraterrestrial asteroids. The other assumes a recent planetary-scale catastrophe on an ancient Earth, driven by internal terrestrial mechanics.
And as the text reminds us, science is not about memorizing a list of right answers from a textbook. Science is a method.
It is a rigorous process of asking questions, formulating hypotheses, and testing them against the physical evidence.
The UTGH framework is offered here not as an unquestionable dogma, but as an opening argument. It is a highly specific, falsifiable framework that attempts to resolve multiple historical anomalies simultaneously.
From dinosaur blood pressure to 360-day calendars to the isotopic signature of the Chixulub crater.
It invites further testing, further questioning, rather than dogmatic acceptance of the status quo.
It demands that we look at the evidence with fresh eyes, without deciding in advance what the evidence is allowed to say. And I want to leave you, our listener, with one final, deeply provocative thought directly from the very end of the UTGH framework.
The distant witnesses.
Yes, it's a concept the author calls the distant witnesses. We talked about how the rupture event exploded with the force of 246 Chixulubs, ejecting 10 to the 22nd power kilograms of Earth's crust, water, and organic material into outer space.
Material that reached escape velocity and dispersed into the solar system?
Exactly. If that is true, if this framework is physically correct about the mechanics of that explosion, then a substantial fraction of the regolith, the dust and debris sitting on the near side of the moon, and perhaps even the scattered debris resting on the surface of Mars, is actually material from our own pre-flood planet.
Which completely reframes our space exploration.
We spend billions of dollars sending high-tech rovers to other worlds, desperately looking for microscopic signs of alien life. But what if, when we finally dig deep enough into the lunar dust, the ancient fossilized life we find actually turns out to be our own?